With the ignition switched on and the contact breaker closed, current flows from the positive battery terminal through the ignition switch, the primary winding, and the contact breaker to ground, then back to the negative battery terminal. The current flow establishes a magnetic field around the windings. The field is intensified by the rod-shaped laminated iron core. With engine rotation, the lobe on the distributor cam acts on the heel of the moving contact point at the instant ignition is required. This opens the contacts and stops current flow through the primary circuit. This sudden interruption of current flow collapses the magnetic field, and it returns its stored energy to the coil terminals by cutting across the coil windings. This induces a voltage in the primary and secondary winding. Since the secondary winding has about 100 times as many turns as the primary winding, the secondary voltage can also be about 100 times greater than the induced primary voltage. As the high-tension voltage builds up across the ends of the secondary winding, a voltage level is reached where the spark plug gap suddenly becomes conductive. A spark then bridges the gap between the rotor and the distributor cap segment, and also the gap between the spark plug electrodes. The secondary circuit is from its connecting point at the primary winding to the spark plug and across its electrodes to ground. From there, it is completed through the battery and primary circuit back to its connecting point. Opening and closing the contact breaker switches the primary current off and on. When the contacts begin to separate, the primary current tends to flow on and produce an arc across the contacts. The capacitor absorbs this surge of inductive current by providing an alternative path in parallel with the opening contacts. The capacitor charges to the peak value of the primary winding voltage. By the time this has occurred, the gap between the contacts is too wide for a spark to discharge between them. This abrupt interruption of the primary circuit assists in the rapid collapse of the magnetic field, and hence an increase in the value of the voltage induced in the primary and secondary windings. As soon as the secondary voltage reaches a value where it bridges the gap across the spark plug, the voltage in the primary circuit falls to a value below that of the charged capacitor. The capacitor then discharges back through the primary circuit, causing further induction, a continuation of the spark at the spark plug, and another charging of the capacitor. Current continues to oscillate in the primary circuit until all the energy in the system is exhausted. This will maintain the spark at the spark plug for about 2 to 3 degrees of crankshaft rotation.